Okay, this is Introduction to Logarithms and Exponential Expressions. What is a logarithm? A logarithm answers the question, what exponent do we need to make one number become another number? Example, how many 2's multiply to make 8? Well, 2 times 2 times 2 is equal to 8, so we had to multiply 3 of the 2's to get 8. So that would be the logarithm 3. We would write this as log base 2 of 8 is equal to 3. These two things are the exact same. So 2 times 2 times 2 equals 8 is the same as saying log base 2 of 8 is equal to 3. It took 3 2's to make 8. The number we multiply is called the base, so we can say the logarithm of 8 with base 2 is 3, or log base 2 of 8 is 3, or the base 2 log of 8 is 3. This is the way that I'm going to be referring to it. Log base 2 of 8 is equal to 3. That's how we would say this here. Notice we're dealing with three numbers. The base, that's the number we are multiplying. How often we use it in multiplication is the logarithm. And the number we want to equal is, in our example, 8 above. Okay. So looking at logarithm and exponential expressions, we are always trying to answer this question. So if we're using these numbers, we're asking ourselves 5 to what power gives us 25? Well, we know that 5 squared equals 25. So another way to write this is saying log base 5 of 25 is equal to 2. Notice these arrows here is telling us how we would transform this to an exponential function to a log function and vice versa. Okay. So remember, the logarithmic form is log base b of y is equal to x. An exponential form is b to the x power is equal to y. There are some special properties, and those properties are log base b of 1 is equal to 0 because b to the 0 power is equal to 1. All this is saying here is that anything to the power of 0 is 1. And then log base b of b is equal to 1 because b to the power of 1 is equal to b. So again, this is saying here that anything raised to the 0 power is 1. And this one is saying here, anything raised to the first power is itself. So these properties of exponents you should already know from Algebra 1. Okay, it says rewrite each log equation into exponential form. So we have log base 2 of 16 is equal to 4. And remember, in order to turn it into a exponential form, we have to follow this pattern. So whatever the base is our first number. Okay, so I'm going to write 2. Okay. Whatever it's equal to is our exponent, so 4. And then in order to complete our expression, whatever whatever is next to that base is what it's equal to. So ultimately what we're doing is this. I want you to remember this. Circle that little number. That's your very first number. Then I want you to draw this loop around. What this is saying is that we start with that little base number, so 2. We go over here to the right, and whatever number we pass is the exponent, so 4, and then whatever number we land on with the arrow pointing to it is going to be our equal to, so in this case 16. So 2 to the power of 4 is equal to 16 is the same as saying log base 2 of 16 is equal to 4. Okay? So we're going to do the same thing for every single one. So this is 5 to the 0 power equals 1. This is 12 to the first power is equal to 12. And this is 1/4 to the -1 power, which is equal to 4. Okay, follow that every single time, and you'll be able to write it from log to exponential. Okay. Now it wants us to rewrite each exponential equation into logarithmic form. Okay, so now we're going to do the opposite. So remember, this number here that we started off with, this is the base. Okay, and then this number that it is equal to is the number that's inside the parentheses. Okay, and then the exponent is whatever it's equal to. So technically we could follow the same exact pattern. So notice how I circled the 5, and I'm going to draw my arrow pointing to the 2. So this is going to be log base 5 of 25 is equal to 2. And we're going to do that same thing for every single one. So this is log base 10 of 0.1 is equal to -1. This is log base 8 of 4 is equal to 2/3. This is log base 6 of 1 over 216 is equal to -3. Okay, so that's how to rewrite them back and forth between logs and exponential. Now we're going to look at evaluating each logarithmic expression. Okay, so remember, in order to solve these, whatever it's equal to, let's say x, because we don't know what it's equal to in this equation, we could rewrite this as an exponential. And so this would be 4 to the x power is equal to 64. Well, 4 to what power is 64? This is where you'd get your calculator. And if you don't know it right off the bat, then you would test a few numbers. So let's do, we know that 4 squared is 16. Let's try 4 cubed. Yep, 4 cubed is 64. So 4 cubed is 64, which means that log base 4 of 64 is equal to 3. Whatever number that we find for that exponent is the answer to the equation. Okay. So let's do it for number 2. So remember, we can rewrite this as 2 to the power of x is equal to 32. So we have to think, okay, 2 to what power gives us 32? So let's try 2 to the 4th. So 2 to the 4th is 16. So now we're going to try 2 to the 5th. That's 32. So 2 to the 5th power equals 32, which means log base 2 of 32 is equal to 5. Whatever exponent we find makes that equation true is the answer to our log equation. So we're going to do the same thing for every single one. Okay. So this is 3 to what power is equal to 81? And I'm going to do that for every single one first. Okay, so this is 1/4 to x power is equal to 256. This is 5 to the x power is equal to 1/5. Remember, we don't know what it's equal to. That's why I'm naming it x. So this is 36 to the x power is equal to 6. 512 to the x power is equal to 8. And then 1/125 to the x power is equal to 5. So we have to find what that exponent is. So going back up to example 3, let's try 3 to the 4th power. Yep. So 3 to the 4th power is 81, which means log base 3 of 81 is equal to 4. Okay. Here, since we have a fraction raised to an exponent is equal to a whole number, I know that exponent has to be negative. So first, what I should try to do is I should try to find what exponent, if I was to do 4 to the power of that exponent, would give me 256. Well, 4 to the 5th power, that is too much. 4 to the 4th power. Okay, so this is what I just did. Let me do this little note. Okay, 4 to the 4th power is equal to 256. But since I have 1/4, instead of saying to the 4th power, it actually would be to the negative 4th power. So 1/4 to the negative 4th power is 256, which means that the log base 1/4 of 256 is equal to negative 4. That's my answer. Okay. Same here. Notice I have a whole number going to a fraction. That tells me that this exponent needs to be negative. And since this is 5 going to a 5, it stays the same. So I know that this is 5 to the negative 1 power is equal to 1/5. So log base 5 of 1/5 is equal to negative 1. And that's our answer. Okay. Let's see here. We have 36 going to 6. So now we have a larger number going to a smaller number. Well, I know that 6 squared gives me 36. And the square root of 36 is 6. So how could I write the square root as an exponent? Well, I can write that as a fraction. 36 to the 1/2 power is equal to 6, which means that log base 36 of 6 is equal to 1/2. Okay, so let's see. This is probably something similar. So I have a larger number going to a smaller number. So I'm first going to see 8 to what power gives me 512? Well, 8 cubed is 512, which means that the cube root of 512 will give me 8. So the cube root of 512 is equal to 8. Well, the cube root is the same as saying to the power of 1/3. So this is 512 to the power of 1/3 is equal to 8, which means log base 512 of 8 is equal to 1/3, and 1/3 is our answer. Number 8. Okay, number 8, we were going from a fraction to a whole number, which means my exponent should be negative. So I have to think, okay, 5 to what power gives me 125? Well, 5 cubed, I think. Yep, 5 cubed gives us 125. Okay, but I need the opposite. I need that 125 to give me 5, which is the cube root. So that means the cube root I know is 1/3, but since it's a fraction to a whole number, it has to be negative. So this is actually going to be 1/125 to the negative 1/3 is equal to 5, which means log base 1/125 of 5 is equal to negative 1/3, and that's the answer. So for these, we kind of need to know, okay, go back to our last unit with radicals, that the square root is the same as saying to the 1/2 power. The cube root is the same as saying to the 1/4 power. The fourth root is the same as saying to the 1/4 power, so on and so forth. and that if we're going from a fraction to a whole number or a whole number to a fraction, then our exponent needs to be negative in order to make that switch. Okay. For the next part, it's showing you a way to do this on your calculator. So what I want you guys to do is pause this video, and I want you to go ahead and try these all out on your calculator. We talked a little bit about this in class the other day when I was mentioning that the natural log is the same as saying log base e of x, where e is just a number, 2.71, so on and so forth, just like pi. It shows you here on your calculator that you're going to hit Control and then either e to the x or 10 to the x based on if this is a natural log or a log. And then it's going to pop up and have you fill in the blanks there. Go ahead and do that. Solve these out. I do not have a calculator with me right now to be able to do this exactly with you guys. So go ahead and fill this out. And then when I come back, I'll give you guys the answers to these and we'll see if you did it correctly. Okay. Last part, the properties. So we have log base b of b to the power of x is equal to x, and b to the power of log base b of x is equal to x. So this is pretty much saying that if we have the base that matches that whole number there, so this part right here, the base matches this number, then it cancels out. Same with this. If this base matches the base of the exponent of log, it cancels out. And then you're just left with the exponent. So looking at this, notice how this 5 matches the log base 5 here. So because of that, that cancels out, and our answer is x, because that's what's left over. Okay, those cancel out. Let's see here. Okay. Remember, if we don't see a base, we assume that base is 10. So actually, this is the same as writing 10 to the power of log base 10 of 7. We'll notice how these bases match. Since they match, we cross them out, and whatever is left over is our answer, and our answer is 7. Okay. Same here. We have log base 7 of 7. Okay, well, those cancels out, and whatever left over is our answer. So negative 3x is our answer. Okay, so notice here is where now we don't have something that can just cancel out right off the bat. But we are able to rewrite this where we have the same bases. Excuse me. So for example, we see a base 2 right here. Well, I can turn 32 into something where it is 2 to the power of a number. So let's see. 2 to what number gives me 32? Well, remember, we can check that on our calculator. 2 cubed is 8. 2 to the 4th power is 16. 2 to the 5th power is 32. So this number right here is 5. So this is 2 to the 5th power is equal to 32. Well, instead of writing 32, I'm going to write 2 to the 5th power. So this is log base 2 of 2 to the 5th power. And remember, there was still an x up there in the exponent. So I'm just going to bring the x down. Notice now that I have the same bases of 2 in both the log and in the base of my exponent, which means these cancel out and I am left with 5x. 5x is my answer. Okay, so if the bases don't automatically match up for you to cancel out, you need to see if you can turn that into a base that is able to cancel out. And then if you're not able to do any of that, then it can't be simplified. Okay, this one, so notice here we have a base of 5, and then we have our number here of 25. So I have to think, 5 to what power gives me 25? Well, 5 squared equals 25. So I could rewrite this as log base 5 of 5 squared, and then bring down that 3x in parentheses, which means that the log base 5 and 5 cancel out, and I am left with 2 times 3x, which is equal to 6x, and that's my answer. And then last one here, remember if we don't see a base in the log, we know that base is 10. So this is the same as saying log base 10 of 1,000 to the power of x plus 1. Well, I need to make that 10 and this 1,000 have a base of 10. So 10 to what exponent gives me 1,000? It's where you go to your calculator and check. And you'll be able to find out that 10 cubed is 1,000. So 10 to the power of 3 is equal to 1,000. So I'm going to rewrite this as log base 10 of 10 to the power of 3. And I already had x plus 1 in my exponent, so I'm going to bring that down in parentheses. Now I have log base 10 and 10 match, so they can cancel out. And whatever's left over just comes down. So 3 times x plus 1. I distribute the 3, which means I have 3x plus 3. That is my answer. Okay, so that is how I would simplify each of these logarithms based on the property that if the base of the log and the base of the exponent match, it can cancel out.